Hello dear friends, welcome to my channel. Today's discussions is stark effect of hydrogen atom degenerate. Degenerate. So friends, using first order degenerate perturbation theory, calculate the energy levels of the n equals to 2 states of hydrogen atom placed in an external uniform weak electric field along the positive z axis. So friends, solution perturbed perturbed Hamiltonian, perturbed Hamiltonian H dash equals to minus E into capital Ez where E is equal to electric electric field, where E is equal to electric field, and En1 is equal to N0 H dash and N0. So and now H0 is equal to unperturbed Hamiltonian equals to P square divided by 2m plus minus E square divided by 4 pi epsilon 0 small r. Ground state of hydrogen atom. Ground state of hydrogen atom ground state of hydrogen atom is psi 100, and so E00 E101 equals to 100Z 100 equals to 0. Now Z is directions, Z direction, Z direction del L is equal to plus minus 1 and del M equals to along Z directions. For first ground state, this is for first ground state n equals to 1. So for first ground state, so friends, ground state, everything you will check my first hydrogen atom atom YouTube video. I have already discussed both postulations. So for first ground state n equals to 1, and so no degeneracy, so no degeneracy. Again, in first excited state n equals to 2, in first in first excited state n equals to 2, then degeneracy is equal to degeneracy equals to 4, n square is equal to 4. So hence the first excited state H, hence the first excited state in hydrogen atom, H atom is fourfold degenerate. N equals to 2 and L equals to 0, 1. For L equals to 0, M equals to 0, and L equals to 1, then M equals to correspondence plus 1, 0 and minus 1, and NLM M equals to 2, 0, 0, 2, 1, 0 and 2, 1 minus 1 and 2, 1, 1. So this is my state. So my Hamiltonian here 4, 4, 4 degeneracy, hence we can take the determinant of 4 cos 4 matrix, that is the H dash 1 1 minus E dash, H dash 1 2, H dash 1 1 3, H dash 1 4, H dash, you can get this Hamiltonian, which is equals to where 1 is equal to in the matrix 1 is equal to 2 1 0, okay, or 2 is equal to 2 0 0, and 3 is equal to 2 1 minus 1, and 4 is equal to 2 1 1. So use this and I get this matrix. Okay, so I get this matrix. Now friends, you see that in here L equals to del L equals to in here 0, del L in here del L equals to 0. So this point is 0, and this point in here del L equals to 1, del L equals to 1, and del M equals to 0, and del M equals to 0. So Z direction selections rule, with the help of selections rule we get this value exists, and this value is 0 because here this value is 0. So similar way we get, because del M, because in here where is that 2002111, okay, in here del L equals to 0. Similarly this portion is also 0, selections rule, apply the selections rule whatever we get, this matrices E dash, and this portion is not zero. Follow the selections rule. By the selections rule, these portions is not zero, so we get this value, and using the value 3 and 0.00 equals to 0. Sorry, this value is 0, and we get the determinant, which determinant E dash whole square, E dash is equal to E dash E square into 3a0 E, capital E whole square, and equals to 0. So I get E dash value equals to 0, 0, 3ae and minus 3ae. So friends, we get E dash value is 4 value we get. Now we are going to a plate, parallel plate. You see that the two parallel plate, this is the machine, okay, where you see that E0 to the n is equal to 2, E0 state 2 state. So in here excited energy and in here unperturbed perturbed dipole, and which is 0 0 0, and in here dipole are anti-parallel, whose value is ea0 ea0 0 plus 3ae capital E and E0 E20 plus, so in here it is minus minus 3ae capital E. So friends, this is the value of the both dipole are parallel. And now U is equal to potentials. Potential U is equal to minus P E. Okay, minus P E, you can write this way. It is very good way. P E. P is the dipole, and E is equal to electric field. It can be minus P E cos phi. So friends, how I get this value 3ae? Because 3ae we get this value, you see that this value is 3ae, okay, this value is 3ae. So how you determine? Because there is a formula. That formula I have to tell you that 2 1 0 and h dash 2 0 0 equals to triple integration capital triple integration 0 to infinity 0 to pi and 0 to 2 pi. So conjugate psi star 200 and r cos theta conjugate psi 200 r square dr sin theta d theta into d phi. So friends, here this equation, from this equation you get this value, okay, and this value is equals to, this value is equals to 3 3e a0 capital E, where E is a electric field and a0 is equal to ph Bohr radius. Bohr radius. Bohr radius. So friends, in here you get a0 values. Okay, in value is a0, I not a0. Okay, this is a0, and dipole, where you see that it is e02. I need to write correctly. This is also E02 and 3AE, and E20 3AE. So friends, PE cos phi. So potential is equal to PE cos phi, where theta is equal to 0, then U is equal to minus P capital E. When theta is equal to pi, then U is equal to PE. So friends, in case of anti-parallel, in case of anti-parallel, we get state is equal to 1 by root over 2 120 and minus 200 and minus w in case of parallel. This is the parallel. In case of parallel, minus w is equal to 1 by root over 2 210. Sorry, it is not 120. I have written wrong. It is 110, because n is equal to 2, 1 is equal to, l is equal to 1. 210 minus plus 200. So this is my states, total states, and 210 and 200 are in z directions, because these states follow the selections rule. Del m equals to 0, del m equals to 0, and del l equals to plus minus 1. So friends, dipole moment in this case 3a0 e p equals to 3a0 e. Now it is remarked that a H atom in the first excited state behave as it had a dipole moment of magnitude 3a0, where a0 is equal to Bohr radius, and orientable, parallel and anti-parallel to the field with two states with no number of component along the field. Okay, so this is my remark. Thanks for watching. I hope I can give some idea a little bit. If any errors, must comment on my sections. Okay, and like or dislike, you can give like and dislike both in my channel, no problem.